Hello everyone, and welcome to week 2 of Abarsa's 10th grade math Google Classroom. This week we'll be learning how to factor simple expressions with exponents greater than 2 and how to factor by grouping. These skills are directly related to the competency of applying polynomial identities to solve problems. As you follow along, take notes on the examples and definitions that are provided. These will be useful guides and can be used on the short quiz associated with this lesson. If you don't have them with you already, pause the video and grab your pen and notebook before we get started. Right, let's get started with a warm-up problem to get our minds thinking in the right direction. For the do now, I want you to factor the trinomial x squared minus 10x plus 21 into a pair of binomials. Pause the video as you try your hand at this problem. When you factor the expression x squared minus 10x plus 21, you need to consider several elements, including the degree of the trinomial, the coefficient of the leading term, the constant, and the signs of each term. These elements all affect the process by which we can simplify the expression. In the given example, we see that the degree of the leading term is 2 with a coefficient of 1. The constant, 21, is positive, and our middle term is negative 10x. Knowing that we want to factor the original expression, we need to perform our reverse FOIL technique and the factorization of the constant. Addressing the x squared term is quite straightforward, since the coefficient is 1 and the exponent is even. Since the middle term is negative and the constant is positive, we know that we must multiply two negatives together when we FOIL. The factorization of 21 is 1 times 21 and 3 times 7. Looking at these factors, we want some combination that will give us a difference of 10. Of the two pairs, 3 times 7 should stand out. Combining all of these steps, we get our two factors, the quantity x minus 3 times the quantity x minus 7. We can check our solution by applying the distributive property. If this was difficult for you, please review the advanced polynomial factoring video linked in the description below. Thus far, our experience with factoring has been limited to quadratics, but the functions you'll see as you advance in your math studies will be more complex and will need a plan of action for addressing them. If you successfully answered the do now, then you're already well on your way to tackling these more complex problems. Take for instance the expression x to the power of 6 minus 14x cubed minus 51. This might appear intimidating right now, but it's no more difficult than the do now if we fully understand the polynomial identities demonstrated in that example. First of all, you should recognize the expression is a trinomial. The degree to which our first term is raised is 6 with a coefficient of 1. The second term has a coefficient of negative 14 and an x cubed. And finally, our constant is negative 51. While the degree of the polynomial is higher than that with which we are familiar, the properties of the expression allow us to treat it similarly to quadratics. The exponent of our leading term is even, which should indicate to you that it is divisible by 2, a good sign when trying to factor a trinomial into two binomials. Specifically for this problem, we can factor our x to the power of 6 term into x cubed and x cubed. We should then consider our constant of negative 51. Knowing that we have to multiply a positive and a negative factor together to get a negative product gives us good insight into our final factorization. The factorization of 51 is not always obvious to everyone, but it is not prime. Rather, we get 1 times 51 and 3 times 17. Since we are dealing with a negative 51 in the example, the combination of these factors must include one negative. Now looking at the middle term, negative 14x cubed, we know that the difference from our factors of 51 needs to equal negative 14. Automatically, 3 and 17 should stand out. When you subtract 17 from 3, we get negative 14. Combining all of these steps together, we get our factors. The quantity x cubed plus 3 times the quantity x cubed minus 17. Note, this is in form and substance the same process we use to solve quadratic trinomials, and it holds true when factoring all trinomials with even leading powers in one variable. Moving forward, let's review another method of factoring by grouping. In the previous examples, we were factoring using a specific method for trinomials and their binomial factorizations. However, what if we have a polynomial with 4 terms? How could we go about factoring this? First, ask yourself, is there anything that factors out of all 4 terms? When we have 4 terms and nothing factors out of all of them, we know we need to consider trying to factor by grouping. To factor by grouping, we first split the expression into 2 pairs of terms, and then we factor the pairs of terms separately. If we've set things up correctly, we should get a common factor in binomial form. Let's try the example xy minus 5y minus 2x plus 10. In this case, we'll leave the 4 terms in their current order, xy minus 5y minus 2x plus 10. What can we factor out of the first pair? We can take out a y. If we factor out a y of the first pair, we have y times the quantity x minus 5 minus 2x plus 10. What can we factor out of the second pair? We can take out a negative 2, which leaves us with the quantity x minus 5. You might be asking yourself, what happened with the signs in the last factorization above? We factored out a negative 2 out of those last 2 terms rather than a positive 2 because the leading sign on the pair was a minus. And we got a negative 5 in the parentheses because when we divided the positive 10 by the negative 2, the result was negative 5. As a reminder, you must be careful with your signs. Now we have a common factor and we can proceed as usual. Let's consider the following example. Let's factor x squared plus 4x minus x minus 4. This polynomial has 4 terms with no factor common to all 4. So we'll try to factor by grouping. Why in the second line above did we factor out a 1? Because if nothing factors out, then a 1 factors out. Sometimes you'll have polynomials with 4 terms having no common factors, and it seems like factoring by grouping isn't working. Before you give up, try rearranging the terms into different groups. Take, for example, the polynomial x squared plus 3y minus 3x minus xy. Let's try factoring this by grouping with the terms in their current order. For the second pair of terms, we need to factor out the minus outside of the parentheses. So we'll need to remember to take the inverse of the signs inside the parentheses. Okay, that didn't work. What if we rearrange the terms? How about if we group, say, the 2 terms that contain the variable x? Oh, so close. If only the subtraction in the second parenthetical was reversed. But let's remember, we can reverse the subtraction. We just have to remember to take the inverse of the sign outside of the parentheses. This gives me x times the quantity x minus y minus 3 times the quantity x minus y. Simplifying this, we get the quantity x minus y, which is our common factor, times the quantity x minus 3. There will be times, as in the example above, when one of the rearrangements of the terms won't quite work. Don't get discouraged. Keep trying all the methods that you know. Now that we've practiced with a few examples, it's time for you to try your hand. Pause the video and try the following problems before checking your answers. Thank you for tuning in. Hopefully you were able to follow along and understand the various methods for factoring polynomials. Check out the links in the description below for further resources to help you master this topic. All of these resources can be used to help you complete the short quiz associated with this week's lesson. As always, feel free to reach out via comments in our Google Classroom or via email. We're always here to help.